In this video, I'll explain how to install Labscript on a Windows 10 PC. We'll go over how to get up and running with the developer version of Labscript using the Anaconda Python distribution. Most of the instructions on how to do this can be found at labscriptsuite.org. Click the Getting Started tab. Then find the link to the installation documentation. This page contains links to supporting documentation on how to install different versions of Labscript. It also goes over setting up a Python environment if you don't already have one set up. So this video will only cover how to install the developer version using Anaconda Cloud. If you have another Python distribution, you can find instructions using pip here, or if you only want a regular Labscript installation, which doesn't allow you to modify or write new device scripts, you can find instructions up here. This computer that I'm using does not yet have a Python distribution installed, so I will now install Anaconda and set up a Python environment. So go ahead and skip ahead if you already have these on your machine. Okay, so installing Anaconda Python in Windows 10. Go to anaconda.com. Click on Get Started. And click Download. You now have a choice between 64-bit and 32-bit. This is something of a legacy option, and for almost everyone, the 64-bit option will be what you want. If you want to double check what your operating system is, just type system into the search bar, hit enter, and look at your system type. Here it is, x64, which means 64-bit. So we choose the 64-bit option, and now we'll wait for it to download. When it's finished downloading, go ahead and click on it to run. Follow the steps in the installation wizard. Use the default options. It's recommended not to include Anaconda in the path variable. Labscript will work just fine with it not being in there. Okay, click Next. And Next again. And click Finish. Yeah, now go to Start and open an Anaconda prompt. Type conda create -n pi38 python equals 3.8, and this creates the environment and names it pi38. and type conda activate pi38. And this activates it for this session. You can now see the environment name in parentheses. It no longer says base. Okay, now we're we're ready to go ahead and do the developer install of Labscript. I think it's helpful here to bring up the instructions from the Labscript landing base here, documentation. We're going to go to developer installation Anaconda Cloud. Okay, and here's all the instructions that we need, although January 2021, there are some slight modifications that need to be done here. Namely, this URL has moved, and I'll show you where. Okay, so first off, I guess this has us all in base, so I'm not sure that it matters if you're in Python in your virtual environment. But maybe we'll just start a fresh session. Okay, so first off, we're going to make a directory, Labscript Suite. This is in the user directory of the lab, whoever else is going to be using this. Okay, now we're going to go to that new directory we just created. And then here, I just realized we're going to be using a command called git because this is hosted on GitHub. There's actually a conda package for interacting with GitHub, and we have to install that. We haven't installed it yet on this computer. So that command is conda install Anaconda channel git. Okay, it's going to download Git. I'm hoping that for the next step you don't need a GitHub account, but we'll see. So you can see, if you look at the URL here, that this was being hosted, this Heisenberg GitHub repository, and it's no longer where we want to look. So if we type in GitHub Labscript Suite, this takes you to the repository for this, and you can see, if you go to any of these, like Labscript devices, that the URL is now something different. And this is what we want to use for these next few steps. So let's see if it works. We're just going to basically be cloning these directories to this local machine. So git clone, and then I wonder if I can copy and paste. Let's see, which one do we want to do first? First we want to do Labscript. I'm not sure that the order matters, but I'm going to follow this to the T. So Control C to copy, and great, it does copy it. And let's see if that works. Great. Don't need to log in with anything. So we'll just go right down the line. Next we do Run Manager. Here's Run Manager. Same deal. Git clone and then the URL. Some of these will be larger than others. Next we'll do blacks. Nice thing about doing it this way is that if it moved again, you would know what to do. Although I think it seems unlikely. Lies. Oops, let's see here. Here's lies. Copying the URL. Git clone. Run viewer, which is not necessary, but could be nice. Some people like it. Labscript devices and Labscript utils. Okay, Labscript devices, an important one for sure. Let's see if I can find, I mean, we know what the other one's gonna be, right? It's gonna be this, I'm sure. And that is it. Okay, now let's go ahead and jump into our virtual environment. Anaconda activate pi 3.8. And now we're going to configure this Labscript channel. So conda config this environment, add this channel, channels, should move my cursor, sorry. Labscript suite. Okay, it's been added. I'm gonna install these setup tools. Conda install setup tools, conda pyqt, pip desktop app. And click yes. Okay, I think for this next code, I'm just gonna copy and paste it. So I don't have to type it all in. I think that'll work. Yep. Okay. Looks like there was some sort of error. Git not found. I guess we'll see if we run into problems. Let's now do the next one. Yeah, okay. So something has gone wrong here. Getting run requirements. Yeah, it's not clear what's going on here. Let's try running that command that didn't work again. Okay, I don't know what's going on. I'm going to stop right there. Okay, I figured out what was wrong. Looks like I had to also install Git in this virtual environment. So you can see what I did up here. I'll just take you through the action again. In pi 3.8, okay, I ran conda install c anaconda git. When I run this right now, it'll say it's already installed, but you'll need to do that before you can run this next command because it requires using Git. And we can see that up here because in the error it says somewhere in here it says git is not installed. Git not found. Git command was not found. Okay. Let's move on. So let's try this again. Setup tools. And moving on, okay, so now we can create a profile. And finally, install the desktop apps. Great. That is it for the installation. And now there's a little bit of setup that needs to be done. So I'm just going to minimize this and this. We don't really need them anymore. If we go and look in the start menu, you'll see that we have some new programs here. Run Manager, Lies, Blacks. These three are the ones that are used mostly. And if you don't know yet how everything talks to one another, Blacks controls all the equipment and devices. Run Manager compiles scripts for running experiments, and Lies is used for looking at the data and analyzing it, hence the name. Typically, one might open up Blacks and confirm that you can interact with your devices, and then write a script to run an experiment and compile it in Run Manager with variables you might change. That runs the experiment, and then look at it in Lies. But actually, if we try to open up Blacks first, we will get an error. Well, first of all, looks like Windows Defender Firewall has blocked some features of this program. Let's just let it communicate however it wants. Okay, but that aside, you can see that there's some issues here. Something about a connection table. Well, we haven't compiled a connection table yet. We haven't told Blacks what equipment is in our experiment and how to interact with it. There's actually multiple problems here, but in general, we also need to set up some sort of configuration. I can also open up Run Manager. See if this starts okay. Yeah, and this starts fine. It doesn't have a Labscript file. It doesn't have a destination to put things. So it's pretty bare bones at the moment. It doesn't have any globals or variables that you might normally see here. Okay, so this is something, I always get a little bit confused here about what to do, but this is partly why I'm making this video. So let's explore where everything lives on the PC, and hopefully this will come back to me. Okay, so if we take a look in Users, SS Lab, you can see that there's now a directory here, Labscript Suite. This is new. This is where most of the action happens. So let's actually just pin this to quick access. And okay, in here we've got lab config, which we should probably go look at, and user lib and Labscript devices. Those three are pretty useful. Yeah, so if we look in user lib, scripts that are used for running an experiment are in Labscript lib. Analysis lib is used for analysis, of course, and these other two you're not going to use too much right away. Labscript lib, open that up. You can see that there's already two folders there, common and example apparatus. So lucky for us, there's already kind of a dummy experiment that's been set up for us to get us going. And you can see there's a connection table here, and then this example experiment.py. Notice everything is a py file. Everything here is based on Python. Okay, so we'll come back to that in just a minute. If you go to lab config, let's see. Take a look at this desktop config file. And oh, I don't have a useful way of looking at files right now. So this is, again, a totally clean computer, totally fresh boot. So you have a choice at this point what to use to look at all of your scripts, how to edit things. People have different preferences. Atom, Sublime. I've been using Notepad++ lately, so I'm going to install that right now. And if you already have something installed, then skip this step. Okay. Quite a lot of stuff here. I think I want the 64-bit installer, is my guess. All right, I'm going to run this. Yes, please. Okay, click next. Read the user agreement. I agree. Next. Sure, I'll take it all. Yeah, let's run it. Great. Okay. Now I have Notepad++ installed. I'm going to open up the config file in lab config for this computer. You can see that it has some basic configuration settings. Looks like right now it's pointing to the example apparatus, the C drive, and it says where things exist. Has different ports for interacting with different things. This is a useful thing to change. So if we wish to have Labscript automatically open up certain files and allow us to edit them, we must change the location of the preferred text editor. So it looks like the default is Sublime. I'm going to change that to Notepad++. Let's see, I'm not totally sure where that exists. Open file location. Okay, that's not what I want. Let's just go to program files and see if it exists there. There it is right there. Okay, so it looks like we want Notepad++ and then lowercase. Not sure if case matters. It probably does. Looking through the rest of the config file, I think this all looks good to go. The important thing here is that after we've tested this out with this example file, we may want to create a whole new apparatus, named apparatus. Maybe it's for Ramsey Imager or some type of diamond NV center, or whatever experiment you're running. This is relevant to those of us doing NV centers and diamond research, but if you're doing a BEC experiment or mixtures experiment or something like that, you might want to create a whole new apparatus for that. And this is one place where you would have to change the settings. So I'm just going to Control S to save, and maybe I'll minimize that for a moment. And let's see. There's an order of operations here that I always forget. I think that what's worked for me in the past is to load in an example Labscript file into Run Manager for the first time. This is just for the first time. Not run it, but compile it. And then open up Blacks and edit and compile the connection table. And this is just a kind of bootstrapped thing to get going. Could be that this is not necessary, but I'm pretty sure that this will work for us. So just again, in Labscript Suite, we have userlib, Labscript lib. Maybe I will just pin that to the start. Did I do that? Pin, not from start, quick access, here we go. And example apparatus. And then we're going to want to run this example experiment.py. If we want to look at what that looks like, we can open that up. And you can see it has some header, front material here, front matter, and then declaring different devices. And then the experiment principle starts here. It does a couple of very simple things and then stops. Doesn't really do anything real. So to load in a Labscript file, in Run Manager, click on Select a File, and it happens to know we want example apparatus. That's probably because labconfig is configured to look here. Click on Example Experiment, open that. You can see that it automatically generates a place for outputs of this to be saved, including the H5 files it creates. And then with run shot not checked, click Engage. Great. So it did something. You can just ignore this warning about mercurial, and then it says it's ready. So that's good. That means that there are no errors here. Going over to Blacks. Let's just close it and open it again. Oh, where'd it go? Here we go. Now would be a good time also to, yeah, okay, it still gives an error, to go ahead and pin these things to the taskbar. They're probably going to be pretty useful. Okay, so go to Connection Table in Blacks, click Edit, and this should be the connection table that's located in the example apparatus folder. And by the way, if you compare the top half of this, everything above the main part, it should be identical to the top half of this. And as you can see, as I flip back and forth between the two, they are the same. It's an important point in Labscript that for any experiment script that you run, like this one, the thing that you put over here, that it have an identical connection table, identical top half front matter to the connection table. The entire connection table gets pasted, except for this bit at the end here, into the top half of each experiment. And if this gets modified, this must be modified, and vice versa. Okay, great. So it's looking at the right connection table for this experiment. That's great. So we just need to compile it. So click on Connection Table in Blacks and recompile. Pretty sure what this does is interesting. It converts this PY file into an HDF5 file. Anyway, you have to restart Blacks when it's done. Okay, notice now that when Blacks opens up, not only does it not throw any errors, but it now has populated it with two devices, some sort of device called an intermediate device and a device called a pseudoclock. These are not actual physical devices right now. These are just kind of virtual devices, meta devices. But this will allow us to run our made-up example experiment. So now that that's good, Blacks should operate. Again, this is the application that actually interacts with different experiments or different devices in your experiment. And but it can take in a list of commands, that is a script that's compiled from here. So let's just try this out one more time. This time we're going to run this shot, example experiment. So I click engage. Again, it runs without any problem. This time it says submitting the run, experiment added successfully. And if you saw, it happened very quickly. It was added to a queue over here, and then it was run. And I could do this a bunch of times. You could see it'll queue up a whole bunch of these, and it'll run them one after another. Luckily, no errors are being returned here, which is great. So that is possibly a good stopping point. The next thing to do here would be to show you what a real experiment might look like. To do that, I'll probably want to set up a pulse delay generator like a pulse blaster, which is kind of one of the more supported devices at the moment currently for running the experiment and clocking the experiment. And I might set up an NIDAC card, which is also pretty common for lots of physics experiments. Before I do that, I'll just close by showing you where the things that the output files and things like that exist. So that you notice there's this output folder. And just as a quick reminder, if you don't already know this, it's not a reminder, that what's going on here is that in Notepad++, I'm sorry, in this Labscript lib, there's this experiment, which is a script, and it's saying things like, do something, advance the time, do something else, advance the time, do something else, advance the time. It's being read in. Variables that you can define in here are set. It's compiled and sent to Blacks. When it's compiled, what's actually happening is that it's creating an H5 file, HDF5 file, something with an extension H5. And then as Blacks runs it, if there's any data that comes out of it, it is then stored in that H5 file along with all of the settings and, in fact, the entire script for the experiment. And these H5 files are found in the experiments directory, which is in a totally different place. So remember, most of Labscript lives in users, your user, Labscript suite. But the experiments file is in C, experiments. This is a new directory. And in here, you can see it's created automatically a new folder for this particular apparatus, which will hold all of the data and all the experiments that we run, organized by date. And then in here, if I click on example apparatus again, it gives the date, 2021, January 27th. And then you can see each one of these folders is for a different run I did. The first one all the way up to the last one. And if I were to open this up with a viewer and look inside, I would see this script in there, maybe the connection table. And then if it produced any data, the data would be stored in there as well. And if you wish, you can also run, this will make more sense when we have an actual experiment, but lies, remember lies is used for analyzing data, and these did not have any data, I don't believe, so there's nothing to look at. But you can write scripts to analyze an individual shot. You can write scripts to analyze multiple shots. And you can look at each of the shots that you ran, some of their metadata, in here, and control them and rerun them. And you can load any shots you want by clicking on plus, going to where your shots live in memory, for example, like this. Click on a shot, it's an HDF5 file, an H5 file, open, and it loads it in memory. And then if you, I haven't written any scripts here, I don't have any to show, but if you wanted to analyze it, you might have some scripts loaded up. Click on or some routines, click on the H5 file and say it's not done, and it'll automatically analyze it. But there's actually a more convenient way to get your shots loaded in here, so it all happens automatically. So it's automatically analyzed as you're taking in data, which is what most of us want. And to do that, you just, in Blacks, down here where it says Analyze, click on that button. And in this case, because we are doing analysis, because lies, the lies that we want to use, is on the same computer as everything else, just type in local host. Hit enter. There should be a little check mark there. The reason why there's this option, I mean, why would you not have localhost, is many folks decide that they would like to have one computer for controlling their experiment and a separate computer for analyzing the data. This can reduce some of the processing costs and also just organize things, and depending on what you're doing. So down here instead, you might put in the IP address or something like that, the location of the other computer, host name of Lies analysis server. Okay, that's what you want. But now you'll see if I run a shot, okay, so I'm going to run a new shot, and in Blacks it'll load it here, and then when it's done, it'll send it to Lies. So there's a nice little control flow here. So hit engage, runs it, finishes it, and then it automatically appears here in Lies to be analyzed. Okay, I think we'll stop there, but hopefully there'll be another video on how to do this with real equipment. Thanks for listening.